second or two here to get my camera switched up and the cam set up. Okay, I should be able to change. Yes, good. All right. So that's in. And then we need this over here, yeah. And this comes here. Ooh, I can't have my mouse and that in at the same time, huh? Let's try like this. Okay. All right, give my computer just a few minutes to stop shitting its pants. The dot cam fired up and we can get rolling. We are almost done with the semester, guys. Today is our last class. So congratulations for hanging in there and sticking to it. I know it has not been easy for any of you, and I'm very proud of all of you for the work that you've done here. Camera is not connected, but it is disconnected. See, I show you right here. There it is. Go. All right. Okay, make sure the recording is going, get into speaker view, and then we'll share the screen with the dot cam. Wow, my hair looking a little crazier than normal today. Don't matter though, because we're gonna watch this instead. So, like I said, today's our last class. I want to make sure everybody's super duper clear on how exam 4 and the final are going to work, because we don't have any more official class meetings. Kind of seems like the sort of thing we should make sure everybody is clear on. And then I'd be down to do pretty much whatever you guys would like to do. We covered all that I feel is necessary for us to cover from the sequences and series section. So we can look at some homework problems from this most recent homework or some homework problems from earlier. We could talk about the final and what material is going to be on there. We could look at some practice problems for that. Whatever you guys want to do, I am game for today. But first, some distractions. So, announcements. Exam 4, which is the take-home / project style thing, is up in Canvas now. And I have directions there. You can find it under the Files tab or under the announcement titled Exam 4. The exam is only like 6 questions long, 6 or 7 questions long, but they're all free response questions. And they're all to do with polar coordinates, parametric equations, and sequences and series. If you have access to a printer, or if you are comfy attaining access to a printer, my advice would be to print the test and to work on the sheet there. I can show you what I mean. There's just a lot of stuff. There's just a lot of stuff on it that would be a little more difficult to draw by hand. So I guess here, let me do it like this. This. There we go. So here's the file. A fair amount of it is graphing. And for these graphing problems, I give you a coordinate axis that's kind of got these useful tick marks and these helper lines, and it's kind of set up in a way that should help you most conveniently graph this function. For the polar graphing that follows that, I gave you some kind of polar graphing paper to work with here. So you've got these concentric circles and these radial lines at multiples of pi over 12. So this guy exactly halfway in between in quadrant 1 would be pi over 4. This guy down here, the second line up, that's pi over 6. So it's like pi over 6, pi over 4, and pi over 3, pi over 2. But you've also got all the multiples of pi over 12 there to kind of aid you if you're having a hard time graphing in polar coordinates. So that's the first couple problems are straightforward. You know, here's a Cartesian point, find the polar coordinates in a few different ways. Here's a polar equation, graph it in rectangular coordinates, and then graph it in polar coordinates. A third problem, I give you a set of parametric equations. X of t is cos of t, y of t is 2 times the sine of t, where t is allowed to run from negative pi over 2 to pi over 2. Graph the thing, label the initial and terminal point, draw arrows indicating the direction, the orientation. And then we've got some sequence problems. Find the first 5 terms of this recursive sequence. I give you the initial conditions here and the recursion relation here. And then some problems with sigma summation notation. So you're going to compute each of these sums. Nothing too difficult. Just make sure you pay attention to the starting and ending indices and make sure you write them all out before you give me the answer. So I do not just want the answer here. I don't just want the number. I want you to show me the sum written out without the sigma notation and then the answer. All right, so by writing them out and simplifying. Give you a problem here where you're going to find the nth term of the sequence, and that is it. Okay, so nothing too difficult. I know you're all capable of doing this stuff, and you can take your time on it. This isn't due until the day of the final, and on that day I'll accept the take home up to midnight, so you don't have to have it ready to hand in at the final. That way, if you need to split your time up between working on the take home and prepping for the final, you're free to do so. So this is due on the day of the final. Scans of your work. Are due in Canvas on the day of the final, which for you guys, I just don't trust my memory anymore. Oh, it was the 30th. Yeah, the 30th. All right. So that's exam 4. It's a take home. You cannot use any online resources. Don't Google anything. Don't talk to anybody else about the test, including your classmates. I just want to see your work. You are welcome to use your notes. You are welcome to use your textbook. That's fine. Just show me your work with this material. Okay, there's not a long test. I don't think anybody will have a terribly hard time of it if you've been doing the homework. If you are desperately stuck on something and you find yourself tempted to contact somebody else for help or tempted to Google something, send me a Canvas message instead. Right? Think of it like raising your hand during a regular test. You know, I'll come by and talk to you and give you a little hint and do whatever I can within what's reasonable to get you going in the right direction. And I would much prefer that over having to sort out some sort of academic misconduct issue. So that is exam 4. It's available now, and it is due on the 30th. So I just got a PM asking if we're going to have a review or a study guide for the final. I don't have one planned, but I could put something together. See, I don't want to overwhelm you guys because you have the take-home test to be working on. I don't want to give you too much other graded work in preparation for the final. So my advice would be to go back over the old homeworks. To study for the final, especially since the final is going to be in WebAssign. Go over all the old homeworks and previous exams. And that would do a good job. And if we wanted to have a dedicated review session, I would be into that. I think on Sunday, I'm going to do a big review session for college algebra. And I would be willing to do a similar thing for you guys, since your test is on the 30th. And what day of the week is that again? That's a week from today, right? So it's a Thursday. Sunday might be a little bit soon, but we can have a big review day. When works for you guys? Give me an idea of when you would like it. Probably not Thursday. Thursday is not giving you any time between the review and the test. But Monday, Tuesday, Wednesday, what are your thoughts? Just go ahead.
I would prefer Tuesday if that's possible.
Okay, let's hear from some other folks. Anybody else especially want Tuesday or especially want a different day? You can type in the chat or talk to me here. Either one is fine. Is there anybody who would like to come to a review session that would not be able to come on Tuesday at 2 p.m.?
Tuesday, what's the date?
Isn't it over 45?
The 8th?
The thing, because it's finals week, you might have another exam that day. You might have another exam that time. So I want to make sure that whatever we do is something that everybody can come to. I see here in chat there's a few people who are not available on Tuesday at 2.
Yeah, so it would be the 28th is the Tuesday you're talking about?
Yeah.
Yeah. Okay. Yeah, that would be fine.
So here, let's do it like this. You guys use Doodle? It's a polling system. I will put together a poll. Actually, this might be a bit of a pain in the ass. Let's not do that right now. Wednesday. So for my people who said they cannot do Tuesday, I see Josh, Emily, and Zach. Is it all day on Tuesday that you guys are busy, or is it just Tuesday at 2 p.m.? Is there a time that we could move it to rather than having it at 2 that would work for you guys? Emily says Tuesday morning could work. What about Zach and Josh? Tuesday after 4. Just can't do Tuesday all day? Andrew says Tuesday after 4 would work. How about Wednesday? Yeah, I'm kind of leaning towards, let's do 2 of them, okay? Normally we have class Monday through Thursday at 2 p.m. I see, so Josh has a test on Tuesday at 3:30. So we're gonna do 2 of these. We'll do Tuesday at 2 p.m. And we'll do another one Wednesday. And I'm looking specifically to my people who are unable to come to the Tuesday one at 2. What time on Wednesday would work well? So Zach, Josh, Emily, Andrew. We could do Wednesday at 2, Wednesday at 1, Wednesday at noon. Emily says anytime Wednesday is good. Anybody else? 2, free all day. All right, Tuesday and Wednesday at 2 p.m. Those are our reviews for the final. Now, it's your responsibility to go through your homework and find questions you want to work, right? So make sure that whichever of these, or if you're going to come to both, that's fine too. Make sure whatever you're doing, that you are coming prepared with questions to ask for us to work. And we'll have those each be like hour and a half long review sessions for the final exam. The final will be in WebAssign. And there is a specific time window during which I have to do this. Yeah, 1 to 3. Now remind me, with your group, we used the WebAssign lockdown browser last time, right? We haven't used the HonorLock yet, is that correct?
No. Yeah, we use the other one. We haven't used HonorLock, I don't think.
Okay. How many of you guys, you can use the React button there. How many of you guys have used HonorLock for some other class this semester so far? Since everything went crazy. Yeah, no. Okay. Yeah, this is the thing, right? So I would really like to have HonorLock because it does a bunch of shit that the lockdown browser doesn't. It records your webcam, it records audio, and it records what you do on the computer, which for my peace of mind is really nice. But I also acknowledge that there have been some problems. I've had a lot of success running it with my Calc 2 group. I've had very little success running it with my college algebra group. And the biggest thing seems to be like you have to follow their instructions exactly to the T in order for it to work. But since they're going to be so overwhelmed, so if something does go wrong, yeah, it's true. And when they do that, when they flag you for something stupid like that, I review it and you'll be fine. Like you'd never get in trouble for just like sneezing or looking sideways. I'm a little bit conflicted between using HonorLock or the lockdown browser for our proctoring mechanism on the day of the final. I want to first and foremost make sure it's something that works. I don't want anybody to not be able to take the final because of some issue with this. So here's what I'm going to do. I'm going to open an HonorLock practice quiz in Canvas. It's not for a grade. And if that goes well, if you run into problems with it, so you need to take this. ASAP, like today. It'll be open within 5 minutes after class ends. If you run into problems, let me know. If nobody has problems, then we're going to proctor this thing with HonorLock because it will give me more confidence that the grade we're assigning is the appropriate grade and that things are being done as they should. And it'll get the administration off my ass a little bit because they are on us pretty hard about this right now. But if there are problems, let me know immediately. And if we can't fix those problems quickly and simply without causing you trouble, then we'll do the lockdown browser instead, because that seems to be a little bit more compatible with most folks. At least seems to cause trouble less often. But the final is going to be at 1 o'clock on the 30th, which is a week from today, and it will be proctored via one of those two things. Any questions about the testing structure and how things are going to round out at the end of the term here? Any questions for me about HonorLock or the lockdown browser? I know that last time we ran the test with the lockdown browser, it wasn't completely smooth. There were some issues. Does anybody have any concerns about using the lockdown browser? No, you will not have to pay for HonorLock. So I will get you guys tokens for HonorLock. We're supposed to get an enterprise license for HonorLock, which means we don't even have to fuck with tokens. But right now, at least, we're still on that token system. So if we end up using HonorLock, which I prefer to do, then I will email everybody an individual email with your token for the final, the morning of the final. I'm not sure how many questions will be on the final. I haven't written it yet. Since I'm building it in WebAssign, I'll be able to get an approximate time for each of the questions. Like it gives me those statistics, how long it takes each student to enter the answers. And I'll make sure that the test is built so that there is more time than is needed, but only a little bit. Probably somewhere around 15 to 20 questions. What else are we wondering? What's on your mind? Even if it doesn't fall into one of these obvious categories, just talk to me. What else are we worried about? What are we thinking about? The final is going to be a mixture of multiple choice and free response stuff, but it will all be in WebAssign. So in a sense, it's all sort of multiple choice-y, but there will be problems where you have to type in an answer. So it's not all multiple choice, but it will be very similar to the homework questions. So I'll be pulling questions from the same pool for the final that I pull from for the homework. They won't be the exact same questions, but they'll be the same style questions as you see in the homework. What else is on our minds?
If we're doing the honor lock one, are we still in a situation where we will have to show all our work and send it in?
Yes, I'm still going to ask you to scan and submit your work. But but that's just for the purposes of partial credit. So I can go through and look at your work, and if there's something where you did all the right shit, but you entered the answer incorrectly, or there's a typo or something like that, I can still give you partial credit. It's also a little bit for exam security purposes. But with the honor lock, I would be able to be a little bit more confident and have to be a little less fine-tooth comby than I would on exam 3, or if we were to use the lockdown browser instead. But yeah, either way, you're going to have to write out your solutions. And scan them. And submit it on WebAssign. Oh, sorry, on Canvas. Just like exam 3. So the idea behind doing exam 3 like that was kind of as procedural practice for the final. So yeah, the same mechanisms. Everything's going to go the same as it did for exam 3. Just we may end up using HonorLock instead of the lockdown browser. Did anybody hate the lockdown browser? Anybody really not want to use that? Just so I can have this stuff. Yeah.
Just for the record, I'm really frustrated with either of it because I am required to use my laptop rather than my desktop because I don't have a webcam for my desktop. So, I mean, no good solution, but at the same time, it's really frustrating. The whole system is kind of one of the reasons why I avoided taking math online to begin with.
Yeah, I feel the same way. I really do feel for you guys, and it sucks. Math is such a hard subject, and doing things online like this does not make it any easier, and those sort of frustrations I empathize with a lot. If I'm hearing you right, the webcam is one of the big frustrations there, and if we were to use the WebAssign lockdown browser, you wouldn't need your webcam, right? That's only required for HonorLock. Andrew, when you say it's glitchy and slow, are you referring to HonorLock or the WebAssign lockdown browser that we used on exam 3? browser we use for exam 3. Okay. So there's some mixtures here, right? Some people really don't want to mess with HonorLock for lots of understandable reasons, and some people really dislike the lockdown browser, again, for understandable reasons, like Andrew just described in the chat there. We have to pick one, and here's kind of the deal, right? If we use HonorLock, then I don't have to be as stern when I go through your written work and say, okay, well, if all the written work isn't here, I have to mark this as a 0. Because if we use HonorLock, I have other mechanisms to go through and review to kind of give myself the assurances I need that you solved the problem on your own. If we use the lockdown browser, then I do need to be very stern when I go through your work. And if there is a problem for which you give an answer but don't have work justifying it, I'll have to mark that as a 0. So this is kind of the give and take. I understand that both suck for their own reasons from technical perspectives and usability perspectives. But from a grading and academic honesty perspective, HonorLock allows me to be a bit more confident that you solve the problem on your own, which means you don't need to be as careful about writing down every single step on your Scratch work. So if you like that, then you would be in favor of HonorLock. The lockdown browser is maybe a little bit less frustrating to use and doesn't require the use of a webcam, but would require you to write down every single step for every single problem in your written work and scan that right away after the final. So maybe we could take a little vote here. We've got folks in here. So we're going to use the little react options in Zoom, and I'm okay with us voting on this. So if you would prefer to use HonorLock so that you don't have to write all of your solutions in as much detail, you'd still have to write your solutions and scan them, but you don't have to be as nervous about showing every single step or anything like that. If you would prefer to use HonorLock and do that, go ahead and give the thumbs up reaction in Zoom. All right, I'll wait just a second or two more for folks to find that button if they want it. Okay, and then if you would, so go ahead and knock back that react. I got you guys both counted. If you would prefer to use the lockdown browser, but have to write out all of your solutions very, very carefully and scan them immediately afterwards, go ahead and give the thumbs up. Okay, that's pretty clear. And I'm okay with that. It's something that we've done before, so there's less chance of running into technical issues. So it looks like we're actually, don't worry about the HonorLock quiz, practice quiz then. This will be proctored via the WebAssign lockdown browser. Okay. All right, so the final exam then will run exactly the same as exam 3 did. The only difference is on exam 3, if you didn't show me all of your work for a particular problem, I wasn't super harsh about it. I wrote a lot of comments in there. Make sure you go back and read all that stuff that I said in the comments. So go to the gradebook in Canvas, exam 3, and then look at the comments next to your grade. There's a link there to take you to my written comments. Make sure you read those and make sure you show very, very carefully every single step in your work as you work the final exam, and then make sure you scan and upload those immediately after the test. With those things in place, I'm reasonably confident that your work will be your own, but if there are problems for which you do not show work, I am forced in this setting to be ruthless. If you do not show work for a problem, it's a 0, like period. So make sure you show all the work for every single problem, and make sure you get those scans in there quick, like not hours later, definitely not days later, like right then, within a few minutes after finishing the test. I can look and see when you finish the test and when you submit the thing on Canvas. I don't want to see more than like 10, 15 minutes there. Okay? I know it's a little ruthless, kind of sucks, but we're making the best of what we got. If you do run into any technical problems when you try to submit the test or try to submit your written work, just send me a message right away letting me know that you're running into trouble and stay in communication with me, and that way I know there's nothing shady going on. All right, So then, we can work a little bit more with the sigma summation notation. I have a really fun proof of the binomial theorem we can go over, or we can look at some older stuff. We could look at some polar graphing problems, some parametric curve problems. We could dig back further to look into some more straight trig stuff. What would you guys like to look at today?
Homework 12, it was number 16.
So they say the position of an object in circular motion is given by the parametric equations below. Describe the path by stating the radius of the circle, the starting position or the position at time t equals 0, and the orientation of the motion. Then tell them the time that it takes to go around 1 revolution. Okay? So x of t here is 4 times the sine of t, and y of t is 4 times the cos of t, which is not how we're used to seeing it, right? When we see a circle described in parametric equations, usually the x's are the cosines and the y's are the sines. So this is a little different than we're used to, and in order to get a feel for it, to answer their questions, we need to find the radius of the circle, of course, and then we also need to tell them the starting position and the time to go around. Here, if I look at x of t all squared plus y of t all squared, that's 4 sine t all squared plus 4 cos t all squared, which is 16 sine squared t plus 16 cos squared t, which is 16 sine squared t plus cos squared t. And sine squared t plus cos squared t is always 1. So this is just 16. So we get the equation giving the Cartesian equation, normal xy equation, x squared plus y squared equals 16, which is a circle of radius r, a circle of radius 4 centered at the origin. So we know that we're somewhere on a circle of radius 4 centered at the origin. We're on some part of this circle. I guess I'll draw it in with the dotted line to start. And the question is, where do we begin? And we travel as we go around. So, oh, Eddie, are you trying to say something there?
No, sorry.
Oh, no, that's okay. All right, so the question is, where on this circle do we begin, and what direction are we going around, and how long does it take us to go around? To find our initial point, we're going to plug t equals 0. So x of 0 is 4 times the sine of 0, which is 4 times 0, which is 0, right? The sine of 0 is 0. On the other hand, y of 0 is 4 times the cos of 0, is 4 times 1 is 4. So we're starting our initial point is the point 0, 4 up there at the North Pole. So this is our initial point. And then if I'm going clockwise, that means that I would go around like this. So I would draw my arrows in like that. If I'm going counterclockwise, that means I'm going around like this. So I would draw my arrows in like that. Which way am I going here? And how could we figure it out?
We're going counterclockwise because it's positive numbers.
It's true that we're going counterclockwise, and counterclockwise rotation is what we associate with t being positive. We talked before about how swapping t for negative t reverses the orientation of the curve, and that's true. And the standard orientation, even if sine and cosine are switched, is to go counterclockwise. Could anybody give me another way to figure out the orientation? Suppose you don't remember that the standard orientation is clockwise, or that whole t negative t business. How would we figure it out then?
I mean, you just drop a couple values in and see which way they go.
Exactly, yeah, what Ryan said is perfect. Just plug in a couple other t values, right? So this is where we are when t equals 0. We can see where we are when t is a little bigger than 0, like pi over 6 or pi over 4. Plug in some slightly larger t values, maybe pi over 2, and see where you're at. So when t is equal to pi over 2, the sine of pi over 2 is, so let's do it. We'll write it in. To help with orientation, find where we are a little bit later. I mean, I could plug in 0.1 for t if I wanted to, and that's going to give me some nasty numbers out, and I would need my calculator. So I'm going to plug in t equals pi over 2. And when t equals pi over 2, x of pi over 2 is 4 times the sine of pi over 2. What's the sine of pi over 2?
1.
Yeah. So x of t here, or x of pi over 2 would be 4. Y of pi over 2 is 4 times the cos of pi over 2. And the cos of pi over 2 is 0, so this is 0. So it looks like a little bit later, we're actually over here. So instead of going around in the normal anti-clockwise direction, we're going around in the clockwise direction. What's going on with that? How is that possible? Here's another way to think of it. The sine function starts off increasing, and the cosine function starts off decreasing. So my x values are coming from this sine function. So if you look on the interval like 0 to pi over 6, or just some small interval starting at 0, you know that the sine function starts off increasing. That means my x values should be increasing, which means I'm going this way. And cosine, you know, starts off decreasing, so my y values should be coming down. Now that cosine information isn't useful because that would be true whether we were going around like this or around like this. But the fact that the x values start off increasing, that's enough to tell me that I'm starting off by moving to the right. So swapping sine and cosine didn't just change where we start, it also changed the orientation. So this is what my path looks like. We start off up there at the North Pole, and we start walking around like this. What's the time down here when I get to the south pole of the circle? Well, it took me pi over 2 seconds to get from the North Pole to the easternmost point. So it's going to take me another pi over 2 seconds to get from the easternmost point to the South Pole. So this is going to be when t is equal to pi. And we're going to keep going around. We'll arrive over here when t is equal to 3 pi over 2. And then we'll keep going around. And we'll arrive back up here at the North Pole when t is equal to 2 pi. So it takes 2 pi seconds for this particle to walk around the circle, or for this object to traverse the circle, or about 6.28 seconds, something around there. The technique that I would most strongly advise for sorting out orientation is the very last thing I did, where you think about increasing and decreasing. The x values I know should start off increasing, which means that I'm going to start off up here marching like this, because this is the direction in which the x values increase, right? The horizontal axis is still the x-axis. So bigger x values are over this way. Since this function, the sine function, starts off increasing, we know that because we know the graph of the sine function. That tells me that my guy is going to begin walking in some way along this path so that the x values are getting bigger, which means it has to go around like this. Couldn't be going around like this. Does that make sense? So I think we answered all the bits there, right? They wanted to know what's the radius of the circle, how does it go around, and how long does it take to get one revolution? Yeah, so the radius, at least with my numbers here, at 4. The position at time t equals 0 is 0, 4. The orientation is clockwise, and it takes 2 pi seconds to go around. All right, what else would we like to look at here today? It could be anything. It could be from any of the recent homeworks or any of the older ones. If you don't have anything in particular that you want to look at, I do have something to talk about today, and that's that proof of the binomial theorem. But I want to make sure that we're using the time in a way that is best for you, and since the binomial theorem is not a hugely important topic for this class, I would prefer to actually work something that you guys felt would be useful for you. It's been a while since we've played around with exponentials and logs, right? It's been a while since we've done a lot of the inverse function stuff from the early part of the class. It's been a while since we talked about mins and maxes, local extrema versus global extrema. What sort of things are you guys thinking of? Yeah. Exam 2 review, numbers 20 or 21. Let's do it. Just 1 second to pull those up. Yeah, okay. Let's do both of these. So this is from the exam 2 review. Number 20 asks us to solve. I'll write these down and then I'll switch the camera back. E to the x minus 7 equals e to the 3x plus 7, and 21 asks us to solve e to the 3x plus 2 equals 400. We got something else here. Will exam 4 question topics be on the final? Yes. Yeah, the final is cumulative, covers everything from the whole of the semester. Okay. So let's do these. If there's some other stuff, Anthony, that's on your mind, we can take a look at some of those too. So the first equation we could solve a couple of different ways. If you remember the one-to-one property, there's a really fast way to solve this that doesn't require use of any logarithms. If you have two exponential statements equal to each other and they use the same base, something like a to the x equals a to the y, that's true if and only if the exponents are equal. This was called the one-to-one property. So here, this statement, e to the x minus 7 equals e to the 3x plus 7, can only be true if x minus 7 is equal to 3x plus 7. So I can subtract 7 from both sides and add and subtract x from both sides, and I get negative 14 equals 2x. And then I can divide both sides by 2, and I find that x has to be negative 7. So that's the quick path to solve number 20. You could also take the natural log of both sides, and then the left-hand side would become this, and the right-hand side would become this, using the definition of the natural log. And it's precisely that sort of thing that we have to do for number 21. So let's go ahead and do this. Here, remember, to get a variable quantity down from an exponent, we take logs. If you have something like b to the x equals c, you would take the base b logarithm of both sides, or you could take the natural log on both sides. It doesn't matter. I'll write it with the natural log. Why not? And then this simplifies as x times the ln of b, using that rule that powers inside come down. And the right-hand side is ln c. And then I would divide both sides by the number natural log of b. So x would be the ln of c over the ln of b. An alternate approach here would be to take the base b logarithm of both sides rather than the natural log of both sides. And then the base b logarithm of b to the x would just become x. In other words, the log of b would be 1. Here, since this is the base e exponential, the natural log is the natural thing to do. Apologies for the pun. So I'll take logs on both sides, right? To get a variable quantity down from an exponent, you always take logs. In the universe I exist in, the natural logarithm is really the only logarithm worth messing with at all. So I'm inclined to just always use ln. But if you wanted to, if this was like 7 to the 3x plus 2 equals 400, you could take the base 7 log on both sides also. The ln of e to some stuff is always just that stuff. But to kind of remind you what's going on in the background here and how this would look if we had any other base, I'll bring the power down. So this is 3x plus 2 times the ln of e equals the ln of 400. Now the ln of e is just a number, it's 1. The power to which I need to raise e in order to get e out is 1. So this becomes 3x plus 2 equals the natural log of 400. The natural log of 400 is just a number. So I'm just going to proceed as though it's any other constant. I'm going to proceed the same way I would if that was, 5 or pi or whatever. I'll subtract 2 from both sides. And then divide everything by 3. Oh, there we go. If instead of e to the 3x plus 2, I had any other base here, then you would just have to deal with this constant. But for us, since we use the natural log and we're dealing with a base e exponential, the constant on the left-hand side there is just 1. Any questions about this guy or how it would generalize if we had different numbers? Okay, I'm gonna check the chat and see if there's anything else that you guys said you wanted to look at. 21. Oh. All right. What else? I don't see anything else there yet, so we can peruse and play around. What else would we like to look at, guys? What else would we like to play with?
Number 3 from exam 3.
The third problem from the test itself?
Yes.
All right. Yeah, actually, I'm glad you mentioned this. This is one where a lot of folks lost points. So your numbers may be a little bit different, but we're given the value of cosine. We're told that sine theta is negative, and then we're asked to come up with the values of all 6 trig functions. Okay. So this is the problem. Cos theta is 3 over 13. Sine theta is less than 0. Find the values of all 6 trig functions. So first I need to find sine. Once I have sine and cosine, I can find anything I want. Remember that cosine squared theta plus sine squared theta is always 1. So if I plug in for cosine, that's 3 over 13 squared plus sine squared theta equals 1, which implies sine squared theta is 1 minus 3 squared over 13 squared is 9 over, I always forget 13 squared, 169, 196? One of those two. Good old dyslexia.
169.
Thank you. Which means sine squared theta is 1 minus 9 over 169. I can write 1 as 169 over 169. So this is that minus 9 over 169. So sine squared theta has to be 160 over 169, which tells me that sine theta is either the positive square root of 160 over 13, so I'm taking square roots on both sides, right? Sine theta is one of plus or minus the square root of 160 over 169, or sine theta is the negative square root of 160 over 13. I can simplify the square root upstairs a little bit, but before I worry about that, which one of these should I take, the positive or the negative? Where's the information here that's going to tell me? Can anybody tell me what quadrant theta terminates in? Yeah, this is a Q4 angle because cosine is positive and sine is less than 0. Less than 0 means negative. So since theta terminates in Q4, sine theta is the negative square root of 160 over 13. And that is, square root of 160 is 4 times the square root of 10. So this is negative 4 square roots of 10 over 13. Right? 160 is 16 times 10. And the square root of 16 is 4. So now that I have cos theta and sine theta, I can find anybody else that I want. So here's my first guy. Sine theta is this. Tan theta then is always sine over cosine, so sine theta over cos theta, which is negative 4 square roots of 10 over 13 divided by 3 over 13, which is the same as negative 4 square roots of 10 over 13 times 13 over 3. Cancel the 13s, and you get negative 4 root 10 over 3. So that's tan theta. And then the other guys are easy to come up with just using the reciprocal identities. Secant is always the reciprocal of cosine. Cosine is 3 over 13, so this is 1 over 3 over 13, which is 13 over 3. Cosecant theta is always 1 over sine theta, which is 1 divided by negative 4 root 10 over 13, which is negative 13 over 4 times the square root of 10. And cotangent theta is always the reciprocal of tangent, which is the reciprocal of negative 4 root 10 over 3, which is negative 3 over 4 square roots of 10. Okay, so these are all metric functions. Any question where any of these are coming from? Okay. I think we have time for one or two more. What else would you guys like to look at? From exam 3? So here we're told that sine theta is negative root 3 over 2. And we want to solve the equation for theta and then give 6 specific solutions. So this is a trig equation. So it has infinitely many solutions. So they want us to solve sine theta equals negative root 3 over 2. The trick for me on these is always to draw the unit circle. If I give a quick little sketch of the unit circle, I know that for sine theta to be negative, I have to be down here somewhere on the lower half. And I know that the reference angle that gets me to a sine of sine being negative or positive root 3 over 2, that reference angle has to be 60 degrees or pi over 3. The point down here being 1/2 comma negative root 3 over 2. And then the symmetric point for the other fundamental solution is over here at negative 1/2 comma negative root 3 over 2. And you can describe these using a bunch of different angles. I would be inclined to think of this first guy as coming from theta equals negative pi over 3. But you could also measure it the other way. And then it would be, let's see, 5 pi over 3. This fella, the other fundamental solution, I would say that's coming from theta equals pi plus pi over 3. That's 4 pi over 3. Now you don't have to use these as your fundamental solutions, but I think these are the most natural choice of fundamental solutions. If you prefer to use, for this guy, theta equals 5 pi over 3, that's fine too. But we get the two fundamental solutions. Theta equals, you could go with 4 pi over 3 and theta equals 5 pi over 3, but I'm going to go with calling that guy negative pi over 3. But this is the important step to getting these problems right. Yeah, you find any point on the unit circle that satisfies that equation. And how you describe those points is up to you. But make sure that you identify any point on the unit circle that has the sine of theta being negative root 3 over 2. And these are the only two. We know they have to be quadrants 3 and 4 because that's where sine is negative. And we know the reference angle has to be 60 degrees because that's how we get the sine being root 3 over 2. So then I extend both of these periodically. So the periodic extension, since sine is periodic with period 2 pi, would be theta equals 4 pi over 3 plus 2k pi, or theta equals negative pi over 3 plus 2k pi. And that's all the solutions. The other thing they ask us to do is to find 6 specific solutions. And we can find those by plugging in numbers for k. So to find you plug in 4k. Any integers you want. 0 is always convenient, so like taking 4 pi over 3 and negative pi over 3, you get those easy. We know those are 2 solutions. Those were our fundamental solutions. If I plug in k equals 1 here, then I get negative pi over 3 plus 2 pi. And if you have a common denominator there, 2 pi is the same as 6 pi over 3. 6 pi over 3 plus negative 1 pi over 3 is 5 pi over 3. When k is equal to 1 in the other guy, we get 4 pi over 3 plus 2 pi. And again, 2 pi as a ratio over 3 is 6 pi over 3. So 4 pi over 3 plus 6 pi over 3 would be 10 pi over 3. So now I've got 4 solutions. And I can plug in k equals -1 or k equals 2. Why not? So my negative pi over 3 plus, when k is 2, that would be 4 pi. And 4 pi as a ratio over 3 is 12 pi over 3. 12 pi over 3 minus 1 pi over 3 is 11 pi over 3. And the other guy would be 4 pi over 3 plus 4 pi, which is 4 pi over 3 plus, oh, did I do that right? Sorry, hold on. Need to write this as a ratio over 3, right? Yeah, no, that's right. Okay. 4 pi, if I want to write that as a ratio over 3, is still 12 pi over 3. And 12 pi plus 4 pi would be 16 pi over 3. So here are my 6 specific solutions. These aren't the only 6 you could give, of course, right? There's infinitely many solutions. And as long as you write down 6 ones which are correct, you'll be good to go. But plugging in 0, 1, and 2 are natural choices for k. You can plug in 0, 1, and -1, or 0, 1, and 5, or 10, 12, and 36 if you wanted. But the trick there is to find your 2 fundamental solutions, make sure those are correct, and make sure that that's all of them. There aren't always 2, right? Sometimes there are only 1, but you get those from your unit circle. Then you extend using whatever the period of the function involved in your equation is. Here, this was the sine function, so its period is 2 pi. So I had to extend by multiples of 2 pi. And then if you want specific solutions, just plug in numbers for k.
Do the numbers for k always have to be positive? Like
Nope.
you can't minus anything?
You could. You totally could. Yeah, you could plug in -1 or -5 for k. That would work just fine.
Okay.
Any other questions on this guy? Solving trig equations is tough, right? We spent a long time on that because it's not easy stuff, and it's definitely one of those important skills. I think we have time for one more. What would we like to look at? Okay. So we're going to look at number 15 from homework 13, from the recent homework. Good. Yeah, this is a great question. So they want us to find S1, S2, S3, S4, S5, and S6. For the sequence whose first few terms is 4, 8, 12, 16. And I'll switch the camera back here in just a second. Okay. So here's the task. Find S1 through S6 for this sequence. So first, A1 is 4. All right, just notation. A2 is 8. A3 is 12. A4 is 16. What's A5? What are we doing here? How do I go from one term of this sequence to the next term of this sequence?
Add 4.
Yeah, right. This is an arithmetic sequence whose common difference is 4. So A5 would be 20, and A6 would be 24. And this is what I need to calculate those partial sums. To find S1, S2, S3, S4, S5, and S6, I need A1 through A6. While we're here, though, we might as well observe that AN is arithmetic. So it's writable in this form with the particular choice. Oh, no, I won't even bother. Let's just say the sequence AN is arithmetic with common difference 4. Okay. To find the S's now, I just need to remember the definition. Well, Sn, remember, is A1 plus A2 plus A3 out to AN. So S1 is just A1. S2 is A1 plus A2. S3 is A1 plus A2 plus A3. S4 is A1 plus A2 plus A3 plus A4. S5 is A1 plus A2 plus A3 plus A4 plus A5. And S6 is A1 plus A2 plus A3 plus A4 plus A5 plus A6. So S1 is A1, A1 is 4. S2 is A1 plus A2 is 4 plus 8 is 12. S3 is A1 plus A2 plus A3 is 4 plus 8 plus 12 is 24. A sneaky way to compute S4 is to notice that S4 is the same as S3 plus A4, right? These parts are the same. So to get S4 from S3, I just have to add A4 to S3. So A4 is 16, S3 is 24. So I'll write down here how I'm doing the computation. S4 is S3 plus A4 is 24 plus 16 is 40. And then S5 is the same as S4 plus A5 is 40 plus 20 is 60. And S6 is S5 plus A6, which is 84. So the trick here is to remember that the nth partial sum is what you get when you add up the first n terms of the sequence itself. Make sense? All right, I think that's where we're going to finish it for today. Thank you guys so much for being so wonderful all semester long. You guys have really been great, and thank you for hanging in there as things got unpleasant at the end, I know, with all of this coronavirus stuff. We have covered everything that you need to make it through Calc 1. You guys, if you're comfy with all the algebra that we've been doing, will survive Calc 1. Remember how to simplify stuff like this. right? Your first few weeks of Calc 1, dealing with that difference quotient is going to be hugely important. So making sure you're comfy with and remember all of the function notation shit that we did at the beginning of the semester is going to be a big, big deal. And I will be putting questions about that stuff on the final. So while it's good to, of course, learn the things that we've been learning lately, make sure you also spend some time going back and reinforcing the material that we learned at the beginning of the semester, especially when things get so chaotic. Our brains have this way of just like ejecting the shit we don't use all the time. So use that shit, right? Go back and rework some of those questions that really push you with function notation, average rates of change, and that sort of stuff, graphing. Those are the most crucial skills for your first few weeks of Calc 1, and those are the skills that I'm most concerned about you retaining leaving this class. Everything that we've done in this class will be important somewhere in calculus, but it'll show up at different times. So in preparation for the final, please go back and look at the old homework problems. All right, make sure you're working the new stuff, and I'll go through and clear out my extension requests to make sure you got the ability to get in and work anything you want to. But go back and review the old stuff. All right, and then remember next week on Tuesday and Wednesday at 2 p.m. we're going to have a big final exam review session. Come prepared for those. So go back, look at those old homeworks and see what sort of problems you guys would like to talk about. Remember everything we did with factoring and dividing polynomials, lots and lots of stuff everywhere. So please just try to be comprehensive in your reviewing. Work on that take-home test. I recommend that you print it out because I think that will make life a lot easier, especially on the graphing problems. But however you do it, make sure you've got nice, neat, carefully written solutions to that take-home test ready by the day of the final. Okay? All right, if you need anything from me between now and then, between now and the review, just send me a Canvas message. I will do my normal office hour again on Tuesday, but if you want to talk sometime before then or any other time, just send me a Canvas message and I'd be happy to arrange something, okay? All right, congratulations. You've made it through the coursework. Now we just got to survive the last bit of testing. I hope you guys have a nice afternoon, and I will see you soon.
Thank you.
Yeah, thank you.